Okay guys, in our last video we looked at some properties of logarithms. We're just going to take a brief moment to summarize these properties also for the natural log function. So it says the following is a list of some very standard properties of natural logs. These are worth memorizing. So what would be true about the log of 1? Well, this just kind of goes back to our last video where we recognized that anything to the 0 power would come out to be 1 here. And so when you evaluate it with the natural log function, you just want to keep in mind that, hey, your base is e. So if you want to rewrite this in exponential form, we say e to the power of, I don't know, equals 1. We're going to arrive at a lot of the same conclusions, but I just wanted you to see how we get those. And so the log of 1, no matter what your base, is always equal to 0 because anything to the 0 is equal to 1. So we're going to say because e to the 0 equals 1. How about ln of e? Now this is an interesting one because the ln of e means the same thing as the log base e of e here. And when you look at it that way, we say, well, what is this equal to? Question mark. You can really answer the same question by saying, well, then e to the what equals e. And again, just like last time, we see when log base b of b is taken, we get 1 because anything to the first power is itself. The same thing is true here. The ln of e would be 1 because e to the 1 equals e. Okay. Now the ln of e to the x. This is the same as the last time we looked at this property, except for last time we wrote it explicitly. When we take log base b of b to the x, in other words, take the log base b of an exponential thing base b, they cancel out and we get our exponent here. The thing is just that with the natural log, we tend to not write the base. So again, if I were to write the base, this would say the same thing as log base e of e to the x. And if we're trying to answer this question, rewriting it into exponential form might be helpful here. We say e to the what equals e to the x. The only way this could be true is if we get x here. And so we say, well, why is this? Well, just because of this right here. If we rewrite it, what we're getting is e to the x equals e to the x. Now, what is true if I take, say, an exponential thing base e and raise it to the power of a logarithmic thing base e? These two bases here on the log and on the base of the exponential expression are matched. And so if I were to take this out over here, we say e to the ln of x equals what? I'm going to rewrite this as instead e to the log base e of x equals what? And what I'm going to do also is rewrite this into logarithmic form. So log base something of something is something. Put my arrows in, but I'm going to go from exponential form back into logarithmic form. So first things first, our base is e, and we say e to the power of what? Well, to the power of the ln of e, or the log base e of x, equals what? And you can see because of our one-to-one property of equality that this must be an x here. And so it's worth noting that if you take the log base b of an exponential thing base b, the log and the exponential base cancel, and you get the exponent. Whereas if you take an exponential thing, base b, to the power of a logarithmic thing, base b, those just the same cancel, and we get that argument inside the log. And we could say that this is true just because log base e of x is equal to log base e of x, even though we would write it with ln's. Now, last but not least, if the ln of x equals ln of y, then this is true if and only if x equals y. It's our one-to-one property. So using our properties of natural logs to easily evaluate these, well, I notice that I'm taking the log base e of e to the power of something. And so out of all my properties here, this is like property number 3, where it says if I take the log base b of some base to the power of something, they would cancel out and I would just get a third. Okay. Likewise, if I were taking some exponential expression like a base to a power, which I am doing here, I'm taking e to the power of log base e. This is our 4th property and the other inverse property where these would cancel out and we would just get 8. Now for this last one, we say ln of e. Well, what is true about the ln of e? Well, property number 2 says the ln of e would be equal to 1. And so what we really end up with was 1 over 6. And in this case, we just end up with 1/6. Okay. So with respect to properties of natural logarithms, they are really similar to the properties of logarithms in general.